Right, with the International A-Level P3, October 2022. Question 9 got trig identities and an equation with a sine 3 theta, which is unusual. I'm going to be using a few identities. This one, of course, because I'm aiming to get it all in terms of sine thetas. So I'm going to use cos squared, 1 minus sine squared. I'm going to use the double angle formula for sine as well. There's only one of those. And the cos 2 theta, I'm going to use this version of it because that's the one with sine squared, which is what I'm aiming for. Remember, I'm aiming for all in terms of sines. And I also need sine 3 theta, which I don't know off the top of my head, so I want to work out. So this is what it says in the formula book, the compound angle formula for sine. If I treat the A as a 2 theta and the B as a theta, then that just give me sine 3 theta. So I'll have sine 2 theta, cos theta, and then cos 2 theta, sine theta. I've got to change this one into 2 sine theta, cos theta, multiply by the cos theta. And the cos 2 theta, I'll use this one, 1 minus 2 sine squared times sine theta. Multiplying this all out, this will be 2 sine theta cos squared, and this will be just sine theta minus 2 sine cubed. I'm going to change that cos squared into 1 minus sine squared, and then when I multiply all this out and simplify it, I've got 2 sine theta, another sine theta. I've got minus 2 sine cubed, minus another time 2 sine cubed, which is minus 4 sine cubed. So that's my expression for sine 3 theta in terms of sine theta. Then put it into here, hopefully we can get this what's on the right hand side. The cos squared will change to 1 minus sine squared, which isn't 1 minus sine, but we'll get there. The cos 2 theta is 1 minus 2 sine squared, sine 3 theta, which I've just worked out. And then I'm going to write that bottom line like this, and I'm going to treat the top line as a difference of 2 squares. I can write it as 1 minus sine theta multiplied by 1 plus sine theta, and hopefully I'll be able to get rid of this 1 minus sine theta. Now that bottom line, I think it's easy to see if I write it out with x's rather than sine thetas. I'd like a 1 minus sine theta as a factor, so I'd like this to have a factor of 1 minus x, and if you put x as 1 in, you get minus 5 here and 5, so 1 minus x is a factor because putting x is equal to 1 does give you 0. And then the other factor then, well, the first term is going to have to be 1. 1 times 1 gives me 1. The last term is going to have to be minus 4x squared because it's these two multiplied together to give me plus 4x cubed. That middle term, well, I've got a minus x here. I want minus 3x. So this term times this missing one here is going to have to give me a minus 2x. So minus 2x and a minus x could be minus 3x. Quick check. If I do these two multiply together, I've got plus 2x squared, and then multiplying these two together gives me a minus 4x squared, which gives me minus 2x squared altogether. So I can write that bottom line as 1 minus sine theta, which is this term, and then the other one, 1 minus 2 sine theta minus 4 sine squared, which is actually what I want. But I think if you got to this stage and then written that bottom line, because that's what you're aiming for, I think you'd be all right. You didn't have to do any of this. Cancel out these 1 minus sine thetas, then I've got what it says on the right. Then we're solving that equation. So we're going to write this left-hand side like this from the first part of the question, and the right-hand side, all right, it's 2 over sine theta. Then I'm going to sort of cross multiply, put the sine theta up here, and this bottom line up here. So sine theta times 1 plus sine theta is 2 times that denominator. Multiply it all out, and then if I take everything over the left-hand side, I'll have 9 sine squared, plus 5 sine, and then a minus 2. Quadratic formula, I think. Minus b plus or minus square root of b squared minus 4ac all over 2a, or stick it in the calculator. It gives you these two possibilities. This first one is about 0.26938, or you just do sine to the minus one of this, and that gives you 15.6 when you do sine to the minus 1. Remember, when we're doing sine, we need to do 180 minus what the calculator says to get another possible answer, which gives you 164.4. The other one, the decimals look like this, or you just do sine to the minus one of that. The calculator gives you minus 55.6, which isn't in our range of answers. We need everything between 0 and 360, but I do 180 minus that, so it's 180 plus 55.6 gives me 235.6. Not quite finished yet though, because when I've got these first two answers, I can add and subtract 360s off these two to get other possible answers. So if I add 360 to this one, it gives me 304.4.